So welcome everyone. Here we are. We're about to go over lesson 4 of the mentoring program. I think, before I mentioned that we're going to do probably 4 sessions in the building plan phase. So we've gone through the survey, we've gone through the site plan. We've gone through the reading the building plans, and this is what I call part 2 of the reading the building plan. And this brought us to our concrete, our foundation. Okay, and that's what the last lesson was about. If you got a chance to look at it, that'd be great. If you didn't get a chance to, hopefully you can look at it soon. And definitely we'll be, let me see here. We'll be reviewing that. There's a few things that occurred with the concrete and also with the house next door. And what I want to discuss today is the foundation, what is needed for when we do the concrete. Any question and answer on that in terms of the footing, the rebar that goes on the footing, the preparing of the slab, the the grade beams that go in the slab. We discussed that. And one thing that we didn't do, but I know Fode and Eric got to see on site, is how do we calculate the amount of concrete that we need based on the plan. And then we're going to do that like at the end of this and then see how close we came to what actually took place on the site. Okay. Because when you start building, and look, I see people get jerked all the time. When you start to build, we have to know what these numbers are so we don't get messed up. Now, obviously, concrete costs, depending who you're with. We happen to have a good relationship, so we get great prices. But overall, you still need to know how much concrete you need, how many yards you need, because a subcontractor will charge you based on how much concrete they believe you need. So when you have that kind of situation going on, you need to know that you're not getting overcharged for the amount of concrete. And then you can kind of quote accordingly and prepare. So what we ended up doing was I had some predetermined numbers in my head. We definitely ended up exceeding that. And that's because I hadn't fully calculated everything based on what we were studying. But it makes sense, and it definitely adds up. So that we'll save that for last when we do the calculation, so you'll know how to do it, and you know how to get, pretty much get a handle on that. Okay. So before I go through it, for anyone that went or looked at it and I may have some questions, let's go ahead and start some questions, even if it's something previously that we covered. I'm all for that. We can do that too.
All right.
So does anybody have any questions as of now?
Yeah.
Okay.
So like I was gonna say, after you lay like the slab, right? Say like if a pipe is bust like laid on, like how to fix it? Like do you use the same type of cement, or you got to use like a special kind?
Honestly, when you gotta bust up the slab, we just go with regular cement.
Yeah.
Regular cement. We just get bags of cement, we mix it, and then we just cover it, because you're not gonna tear up a large area like that. Like when we order the concrete, we do order, it has to be 3,000 psi. That's the pressure that it has, what it can withstand. And so those are just basic normal numbers and figures that all the concrete companies know you will use. Commercial may go 4,000, they may go a little bit higher on the pressure. But in terms of having to do repairs, so it happens, right? Let's say you have a house, and this is the difficulty of it. Let's say you have a house. Let's say that's a good question. But let's say you went and took over a property. Right?
Yeah.
It's an existing property. It is a new build, right? Or it may just be an older build. And you don't know how the slab you don't know how the foundation was set up in terms of how the water is running and how the drain lines are running. If all of y'all saw the videos, y'all saw how we did the drain lines, y'all saw how the pipes were laid out, and I was trying to explain to y'all how they did the layout based on, let's say, what the sink is, where the bathroom is, things like that, right? We looked at those kind of things. Now, someone that doesn't have access to this, they may not know. So let's say they bought the property, or you bought a property, and there's a slab and there's a leak in the slab, right? And it could be in the drain, or it could even be in the water line, because you saw in the video, we got the water line running from outside coming into the house, running under the slab, and it comes up in different areas, like by the sink, by the garage area. It comes up in different areas on the in the house after the slab is poured. So if you don't see where it was, if you didn't have access to this video ahead of time, you won't know where it is. So if a pipe happens to bust underneath for whatever reason, and then now you need to go ahead and access it and fix it, this is what you need to do. I can't help you so much on the water line, because that one, it's just going to be difficult. But on a drain line, you do have recourse, because we can bring in a camera and run it through the sewer. Okay, my plumbers usually have that. They'll run a camera through the sewer. So they'll either go into, let's say, one of the toilet areas, remove a toilet, and then run a camera through there. Or if you'll recall, I told you about a clean out, the pipe that was sticking outside after the drain came out. That pipe, there's a clean out pipe that sticks out there. He can enter that clean out pipe, he or she rather, and they can then point the camera to run towards the house, right? And they will go through that drain, and hopefully they'll be able to catch where the leak is happening at. It also works for blockages. If there's some kind of blockage in the line, they can kind of trace it. Well, the good thing is with those cameras, they have a way to come inside the house and trace the camera and determine exactly which path the camera is running. So wherever the camera is at, they can come above it with their little detector and detect where, at which point where that camera is. So as it's going through the house, you can follow it. And they can tell you exactly which way it's laying out. And that's how we're able to trace stuff through a drain line. Like I said, the water line can't do too much to help on that, because you just got to do what you can to locate it. But the drain lines, definitely you can go through that. So once you do locate wherever your problem is, then you're going to cut it out with a concrete saw, right? In some counties, what they expect you to do, if you do have to bust up the concrete or cut the concrete to repair something, they do want you to put that plastic back down. So after you repair the pipe, they want you to cover it with that. Remember that 6 mil plastic that's in the video that we looked at? You have to cover it back with that plastic before you pour. They don't really stress you about the wire mesh, but they definitely want you to put that, that plastic down, and then you pour your concrete back over it. I mean, does that answer your question?
Yeah.
Okay. Anybody else? No questions? We're good?
I have some questions, but I didn't. Please pardon me if you said it already, if I didn't
It's
hear
no
it.
such thing. You're good. Come on, come with it.
When you pour the foundation, how thick does it have to be?
Okay. Yeah, you're right. I said it already. I'm not gonna
You
answer.
did. You said it just now tonight?
No, I said it in the previous video. I'm not gonna answer that. Sorry. Yeah.
Okay.
Nah, I'm messing with you. Come on. So let's look at this. So I can go here. Y'all can see the screen, right?
Yeah.
All right. So see if I can put it. All right here. So you see this, Elisa?
Yeah.
You see this right here?
Yeah, a little square. Oh, hold on, let me pull it up. Oh, you say a 4-inch slab. Okay.
4-inch slab.
Okay.
So this tells us what it needs to be.
Okay.
Yeah, this
And
tells
then
us what's that?
and then I see the footings.
Yes. So your footings are 1 foot 8 inches, as it has right here.
Okay.
Right. So we got the you know what? In my other screen, I could do that. You got 1 foot 8 inches wide. And you see this, right? By 2 feet deep.
Okay.
So the cross section is, we know this is the width. So normally we'll come with like their excavator, their mini excavator, and they'll use that to dig this hole. And they'll dig it all around the perimeter. Okay. You follow? Now we say it's the perimeter because what I mentioned in the video is that when you get to the perimeter is what the inspectors are looking for when you do your footings inspection. Okay. When you do your footings inspection, the inspector is going to come out and look at just the footings. And then there's a slab inspection strictly for the slab. So let's look at the footings inspection. So what we did in this particular project, we had to come in here and we had to dig 1 foot 8 inches. So that's 1 foot is 12 inches plus another 8 inches is 20 inches. So we had to dig 20 inches wide. And then we had to go deep. You see the depth right here? 2 feet. Y'all see that?
Yeah.
Okay. So we have to go down 2 feet. In the video, I have my tape measure and I actually I showed it where our width was 20 inches. And then to the top of our slab, you would have had 24 inches, maybe a little deeper in some places. So, and keep this in mind because when it's time to do our calculations for our concrete, we got to do the footings and then we got to do the slab. And then we're going to add it all together based on the formula for calculating volume. And then we're going to put it all together and then we'll get our concrete. So in the end, we are going to do a little math and then, you know, see what we come up with. And then I will share with y'all what we actually did. Okay. So in this particular case, let's look at it like this. We dug this wide, we dug this deep, right? And then if the inspector comes out, he's going to look for that width and that depth. So we passed that part. We're this wide, we're that deep. But then they're going to look for these two right here. Because in our section, okay, let me get. So in our section that we've cut out, our cross section, you have 2 pieces of rebar. Now on the plans, it says reinforcement, you know, 2 number 4. The number 4 is your rebar. And so in the video, I showed what the rebar was, right? So you're going to have 2 number 4 rebar, 1 on this side, 1 on this side. And so in your footings area, you're going to have 1 running this way, 1 running this way, and it's going to go the whole length of the perimeter. That's what the inspector is going to look for. So long as you have the width, 1 foot 8 inches, the depth, 2 feet, and the 2 iron rebars, number 4, because they do have different numbers for different weights. As long as you have that, they'll go all the way around it. And in the video, I actually jumped in the footing and I was walking around as I took that video. Now, within this, let me shrink it more. So within this, all right, I know it's not big at this moment, but it's fine. I'm just trying to show you something. Within this area right here, we're doing the full exterior of the footings. All right. That's it. Now, I did come back in the video and say, after we have our footing, Are there any more? Are there any questions about the footings? First of all, we're good.
Not the
No, so
for the but
Okay,
no,
who
I was
has a
just
question?
I'll wait. I was just gonna say, so that is pretty much trimming all the different parts. Okay, so like for example, on these plans, there are some squares and some rectangles. But like for example, where it says 220, 220, and then it has the 4-inch slab, but it has right there where your hand is.
Mm-hmm.
Why are those footing lines there? Is it because of the roof pitch? Because I noticed when you flashed the roof pitch that it went back to the same thing.
No. So in the video, and that's what I was explaining to, so that y'all would understand. On the exterior, on the perimeter of the house, that is considered your footing, right? However, within your slab, so let's say once we do the footing, we're done. We're good to go, right? We pass inspection on the footing. Now we want to do a slab. Well, the plumbers are going to go in and do their plumbing, right? I showed that on the video as well. After we pass the footing inspection, the plumbers are going to go in and lay the plumbing out, as I was saying, based on the house plan, right? They're going to lay out their plumbing based on the house plan. So the footing's already done. They're going to come in here and then they're going to say, okay, we got a sink here. We got a, shit here. We got a sink here in the kitchen, right? We have a bathroom here.
Okay,
right? We got a half bath here. We got a full bath here. So there's plumbing in all these areas. So the plumbers are going to come in after our footings are dug, and they're going to run their plumbing, all the drains for all these, you know, sink, bathrooms, toilet, all that stuff, you know, they're going to run that. So you're going to see the plumbing pipes in there. And I have that in the video. Okay. So beyond that, after that's done, we're going to get a plumbing inspection. It's a plumbing slab inspection. Those are the phases. So after we pass the plumbing slab inspection, now we can do the slab. Okay. And the slab for us is going to be, let me see here. The slab for us is going to be right here. And here comes the question you're asking, Elisa. Within this, where you see these right here, not the exterior, but the interior ones, that's what you're talking about, right? These interior
Yep.
ones right here. Okay.
Yes.
When it comes to the interior ones, these are called grade beams. They're called grade beams. Now, if you look at it, you can see right here, this one is also 1 foot 8 inches wide. Correct? You see it right here? Where the hand is?
I can see that.
Okay, so that's 1 foot 8 inches. So you're gonna dig it as wide. Okay, and then if we look in our section, this is the slab. And this is our footing. This is our exterior wall, cross section. I think we went over that before, but this is our exterior wall. Well, when you go to the slab, you're dealing with your, you see this right here? Interior wall. Okay. So on your slab, you have an interior wall. So that's what those are. Those are grade beams for your interior walls. But in the cross section of that interior wall, you still have what? Your 2 number 4 rebar for reinforcement. So you're still going to have 2 rebars lying in here. Now, those rebars actually will be lying on top of your plastic. If you saw the video, that's what it is. So what happens when you have that? Why do we have that? I'm going to answer that question, but I'm going to ask one of y'all guys that might know it if y'all saw the video. Why do we have the interior grade beam?
for the grounding, ain't it?
Not for the grounding. Okay.
Is it for the
No, you said those two beams serve two purposes. One purpose is the support, and the other one is grounding the house. Correct?
Okay. So those two, well, we're talking about the actual grade beam itself. The question that Elisa had was
is that the load bearing wall?
It's for load bearing walls. Exactly. Good. So basically what you have here, the reason the engineer drew these, and made us put reinforcement in them, all these here on the inside, is because when we go to the building plan, okay, we have, this is the first floor. I'm gonna playing with. This is the first floor, right? Y'all see it? Now, this is the second floor. If you was to take this second floor and put it directly over your first floor, you can see that the weight of the walls are transferred from the top floor. So never mind that you got your roof, which is sitting on this second floor, okay? But you have the weight of what's the walls on this second floor. All of this has been transferred over to this first floor. So the walls that are here on the first floor, this wall, this wall, this wall, this wall is sitting on these, okay? You have these walls, these are sitting on them. Bedroom walls, some of this wall right here is shared by some of this wall. So he's basically looking at it as, okay, I'm bringing all this load from upstairs onto the walls down here. So I want to reinforce the foundation that this first floor walls are going to be framed on, so that the additional weight coming from these walls, it can support it. So it's best practice. Everybody doesn't do it. The reason it is done in this particular case is because, now, if you ask me, is that overkill? My answer is yes. I've built plenty of houses where I didn't have to do grade beams. In certain areas, we definitely had to do grade beams. So in a way, it's overkill to me. But for the engineer who drew this, he is an engineer. There's a difference between an architect and an engineer, okay? But in our particular case, our architect also happens to be an engineer. So he's gonna go all out and give us the best possible scenario to build the house as structurally sound as possible. So he didn't take any chances. Wherever he felt there was a load, he just said, go ahead and add additional support there, which is great. It's best practice. Maybe overkill, but it's best practice. So if a regular architect drew these plans for you, you might just have the plans without the foundation slab having all those interior grade beams inside. Okay. I've had a plan before where the engineer put like 4 rebar number 4 wires and has some number 5 wire. And everybody agreed it was overkill. But because that's what the engineer put into the plans, that's what the city's going to inspect. So you may have somebody building next door to you, and you're like, well, how come you ain't getting hit for those grade beams? Nah, it's whatever's in your plans. So if your plans have that and is approved, that's what the inspectors are going to see. The very same identical house next door will not have that. It's not a violation, and they can build their house and pass the inspection without the grade beams. Okay, y'all understand that?
Yeah.
Yes.
So it's for foundation. Eric brought up a point about grounding the house, and I will have to pull up the video, but in the video, I showed something in the garage area. There was a piece of rebar that ran all throughout the perimeter, but when it came to the garage, we had one piece of rebar sticking up vertically. Okay, And the question I asked was, why is that? Why do we have this rebar, which is tied into the rest of the rebar and the footing? Why do we have that? Let me bring it down here. So why do we have that rebar sticking up? And I refer to the video because y'all have the video. So when you go to look at it, you'll see, it'll make sense. But the reason we have that rebar sticking up is because the wire, not the wire rather, but the rebar that's running all throughout the perimeter of this property, it is used to ground your wire that the electrician is going to run throughout your house. So when we get to the electrical part of this project, you're going to notice when the electrician wires the house, he's going to tie he's going to tie his ground into a wire. That ground wire is going to tie into our rebar, which is going to be sticking up. Like if you go to the foundation, you're going to see the foundation slab. The rebar is going to be sticking up right here, just by itself. Well, the electrician is going to tie to that. The inspector is going to look for that. When they come to inspect your house, they got to see that ground wire. And it's, we use a term, which is not really a legal term. We call it a UFA. But when we looked at it for the NEC code, the National Electrical Code, it was actually, it's like a concrete encased ground, basically is what it is. So it's a ground, which is your rebar wire, which is encased in concrete. And so if anything hits the house, if any electrical thing malfunctions, instead of you getting electrocuted, everything's going to shoot straight to that ground wire. It's going to go right to the ground rod, which is your rebar sticking up, and that's going to get grounded through that rebar, which is encased in the concrete. Okay, so it doesn't harm you. It grounds the wire, and the house is properly grounded. So these are your grade beams. Interior is your grade beams. The difference, as I said, with your grade beam, although you have it just as wide as your footing, is just for your support walls, whereas your footing is for all your exterior wall, okay? But the interior grade beam is the same width in our plans as the footing. However, the two wire rebars you're going to see are going to be sitting on top after your plastic is pushed down. So what we discussed was, in the video we showed, how is this thing done? You know, how is your slab supposed to look like? So in our slab, I think I had it on here. Let me see if it's on here on the other one. In our slab, we had, okay, that's on the other house. But in our slab, we have the we're gonna have our footing. And then in our slab, we're gonna have aggregate, basically gravel. And I showed it in the video. And also I pulled up one of our other site plans. I'll pull it up again, but it shows you the layout of your slab. This one doesn't show as detailed as the other one does, but definitely it will show you your aggregate. So what we normally have is you have your dirt. So after your footings are done and you go to do your slab, you have your dirt. On top of your dirt is going to be stones, those tiny little gravels. In this case, the crushed gravel that we brought is, we call it number 57 stone. So it's like a, small rocks. And we have some of that in the video. We brought, actually, in this case, we brought 2 truckloads. We dumped it over there. Okay. So then they used their bobcat, their skid steers to carry it. And then they dumped it all over the dirt. This is after the plumbing is done, by the way, right? We talked about the plumbing. Then they're going to dump all the gravel all over to cover everything, give it, reinforcement. And then they're going to come and put this right here, this rigid insulation. It goes on top of the gravel. It's a piece of plastic. If you saw the video, it's a white plastic that we put down. The thickness of it is 6 mil. And if you go any thinner than that, I don't think they pass you for inspection. It has to be at least 6 mil thickness. So we laid that over the gravel. Okay. And then we actually, in our case, we dropped the grade beam wires, rebar on top, because we had made sure that we had it dug this wide. We dropped the grade beam wires on top. So when you saw the video and I'm walking across showing you, you saw all the rebar laying on top of the plastic. After we get that down, then we have a wire mesh, which is also in the video. And then we put that mesh all over the slab, all over the plastic. We cover all of that. That's to help us with the concrete as well, to bind it. So we put all that there, and then we call for inspection. And then the inspector comes out, okay? So when the inspector comes out, he looks at it, he checks everything out, he makes sure that he looks underneath, that we have the gravel there, that we have the 6 mil plastic there, which they label as rigid insulation. And then we have our, our grade beams with the rebar on top. And then we have our wire mesh on top. They see all that, and then they pass us. So what I sent to y'all was a picture of the past inspection. Once we have that past inspection, we're able to pour concrete. You cannot pour concrete unless you've passed that inspection. And those are the steps to get you to where you're able to pour your concrete slab, which is what we did as the final. Okay, now a lot of it, as I'm saying, you have to go and revert back to the video, because of course this is our question and answer part. But if you go back and look at the video for lesson number 4 that I sent out, I break all that down, and then I show you what it looks like in the video, what the plastic looked like, what the rebar looked like. If you don't know what a rebar is, you'll see it. What the gravel looked like underneath, I show you that. Okay, and then we also go through the final phase of getting the concrete poured, and we took different videos on that. So that's where, that's what we were doing there. There was one thing too. We had actually on our plans, even if I look at our site plan, on our plan, we didn't really show, right? This is our site plan. So on our site plan, which is like the layout, right? We know how our driveway is coming in, but we didn't actually show a back porch, or rather the slab, a patio. We didn't show that. So what I ended up doing is, while we were on site, while the concrete guys were framing this, okay, while they were framing the outline of the house, I had them go ahead and put like a 10-foot by 8-foot, 10 feet wide, 8 feet, well, 10 feet wide and then 8 feet, I would say in depth. It'll come out 8 feet, it'll go out wide 10 feet. And I let them do a patio for me back there. So we formed that. We formed all of that so that we can pour it one time. Now, I mentioned to y'all, and I'm going to go back and, get more detailed into it. But I mentioned to y'all that normally the way we would do it is we will have the footings done, and we would do a footings inspection. And then I said after that, we would do the plumbing slab inspection. And then after that, we will prep the slab and do a slab inspection. Well, there's also another way to do it, because just as we passed the footing inspection, we could have just poured the footing, right? We could have literally just poured the footing, which is what goes all around the house. And then we could have let the plumbers come and do what they had to do. And then we could have came back now, prepared our slab, and then we could have poured the slab. That's perfectly doable, 100% doable. So I don't want you to think that you can't do that. You can. But when you deal with concrete, a lot of the concrete guys will tell you, we're going to pour one time. We don't want to pour footings and then come back and pour a slab. We call that a monolithic pour. we're gonna do it one time. So that means we're pouring the footings and we're pouring the slab all at the same time. So when you do it that way, although you do have to have two separate inspections, one for the footings and one for the slab, we wait until after the slab inspection is done, and then we pour the footings and slab simultaneously. So if you look at our video, you will see that in action. You will see where when the first 3 trucks came, they poured it in the footings. We took care of the footings first. The first truck did like a third of it. The second truck did like another third. And then the last truck did like the final third of the footings. And then the rest of it was to do the slab. So that's what they call monolithic pour. So you will hear that. So when they say that to you while you're out in the field, understand that's what they mean. They're going to pour both your footings and your slab simultaneously. We didn't do that on the next lot because I sent a separate video about that one on this house, 4659, because I discussed how we have the elevation. Y'all did see that video, right? But
Some of it.
yeah, some of okay. So when you see the video, and I'm gonna go back to the other slides so we can discuss this more. But on this particular one, we did exactly what we said. We did the footings inspection, and we poured just the footings only. The reason for that is gonna lead us to what's happening tomorrow. We're gonna pour concrete for a wall. We're doing a foundation wall. Okay, so that'll be the next video coming up. That one I'm gonna just share with y'all. I don't have to do a YouTube for that. I'm just gonna share the video with you so y'all see it. Y'all see the panels that we did. So on this particular house, if y'all recall, we talked about how you find the elevation, right? Over here, our elevation is 797, 796, 797, that's 2 feet, right? By the time you get here, you're almost at 800, you know? 799 over here. Let me go with it. Right here, 799. That's what's back here. By the time you hit here, you're at 800. So you're almost about 4 feet, 5 feet from this level where your house is to the back here. Now we dug this down in the back so that we can be at the same level, roughly at 795, so we can have a leveled foundation. This particular foundation is going to be down about 2 feet. So from the garage, you're going to step up about 2 feet into the house. Okay, so if you go to the site, and I'll point it out as we frame it to prepare to actually pour the slab, I'll point it out. You see where the garage is dropped down some, and then there's a little step up, and then the rest of the house is on this level. But because we have such a high elevation here, roughly about 4 to 5 feet from where the house is, we don't have a patio like how we have on the other house. We don't have a patio like here. This particular house, when we built it, we were able to go here and put a slab behind the kitchen. Okay. So at the back of this building, this is the kitchen. There's a door that leads out. And that's why I said we put a 10-foot wide. So like 5 feet on the side of the door, 5 feet on the side of the door, and it goes out about 8 feet. That's the patio. We poured that when we did the slab. Okay. But on this particular house, we don't have that room to pour that. So I'm going to dive into this next, but I want to make sure that we answer questions about this before I go into that house and the wall that's there and how we ended up having to do that differently, because that was part of the video as well. That was like our second phase. There was one thing that was brought out on site. I think Fode, you brought it out, which was a good point, because in this in this right here, in this slab, although this doesn't show you that there's a drop down, because this is our garage, okay? This is the garage area. But it doesn't show you that there's a step down from this garage before you enter the house. But when we were on site, 4-day, you noticed it and you said it. You was like, well, wait a minute. How come you have a step down in your garage? And all of y'all know, if you go into your house, you notice that when you step into your garage, it's a little step down, maybe 3 or 4 inches, step down into your garage, right? And then you have a little border around your garage. So that step down that you have in your garage, you also have it definitely when you have a porch in the back. There's a step down. And so, you know, I explained that the reason you're going to have that is because you don't want anything happening. You don't want your garage, your porch, your patio to be the same level on the same slab as your interior slab. Because any water, anything from outside, if it rains, anything spills, anything that happens on your patio, on your porch, in your garage, it's going to flow right into your house. There's nothing to stop it. So you have to have that step down to prevent that from happening. It's interesting because I seen a house, it was a rehab house, it's a while ago. I've seen a house where they actually poured everything the same level. It was a bad mistake, rookie mistake, because now everything that comes here is gonna, so they have to like cut stuff out and bust stuff out and try to redo it, you know. But if it rains, you can just imagine there's nowhere for the water to stop. So when it rains outside, it's gonna just flow right up under your framing and go right up into your house. You know, there's nothing to break that up. So you definitely have to make sure that there's a step down from your garage, and there's a step down for your patio. There's a step down for your porch. You have to have that. Okay. Let's see. That was one of the things that we brought up. There was a few things that we talked about on site. So I'm trying to remember them so I can bring them out.
I got a quick question while you're remembering.
I think I'm done going down memory lane. Let's do it. Bring your questions.
Do you have to do the core testing for the concrete with residential properties?
No, we don't do any core testing for that.
Why not?
Well, all you need to pass inspection-wise is exactly what we talked about. If your footings are the way they're supposed to be, that gives you all the strength you need. If your slab is prepared appropriately, that's all that you need. So at this point, if you've passed that, the county has done their job. Now, when you pour concrete over it, there's nothing else to test. Now, mind you, so long as you pour 4 inches thick, you're in there good to go. But someone like myself, I could say, okay, you know what? I want a 8-inch pad. I want to have an 8-inch concrete for my foundation. I have every right to pour more than I need. But the minimum I need, so long as I pour the 4 inches, I'm good to go. I think one of the questions that was asked is, okay, is there an inspection after the slab? Like, is someone going to come and inspect your slab? There is no inspection after your slab. What you do is they got to make sure that what's under the slab meets code. So long as you look like you meet code based on what's under the slab, you can pour whatever, you can pour the slab as thick as you want it. As long as you meet the 4-inch, slab, they're fine. They're fine with it. It's similar to a roof. Maybe I want to do architectural shingles. Maybe I want to do a metal roof. Maybe I want to do some kind of fancy roof. The city is not going to care so much about that, but they want to make sure that you put the proper underlayment there. You put the proper flashing to prevent leaks. So they look for those things. So long as you've passed those things, you can go ahead and lay the shingles over your roof. But in terms of why don't you need it, it's not required. So most people are going to build based on the requirement. And if someone wants to do a test, then you have to ask them, well, why? Why do they want to do the test? You know, is there, for a residential, I can't even see it. You know, you're not going to have that much load besides what you're going to build on there. So, did you have to do a testing before for a
No.
client?
Just asking. Are there
Yeah.
any like environmental requirements for pouring concrete?
The only thing that we have for pouring concrete, there are no environmental requirements except one. You're supposed to have a concrete washout. So I mentioned that in the video as well. But so when you look at it, when you pour the concrete trucks have to have a place to wash out the concrete from their chutes. They have to do that. So as a builder, you're supposed to have an area that you dig out. You dig out an area, you dig it out, you dig the ground, a hole in the ground, maybe like 4 feet by 4 feet is good. In terms of the width, you know, the area, and you can dig it a few feet deep. It doesn't have to be very deep. What happens is then you put the plastic inside. You can use the same 6 mil plastic that we use to cover the slab, okay? You lay the plastic inside of it. They actually sell plastic that you can use for that. It's like a yellowish one that we usually buy. It's thicker. It's actually much thicker than the 6 mil. And then we lay it inside of that, that pit that we dig. And then the concrete people are supposed to wash out their concrete into that. At the end of the job, you have 2 options. You can dig it up and haul it out, or you can cover it with dirt and do your landscape. Either or is fine. In Union City, I had that issue happen. Okay, early on when I was building, we didn't realize we had to have that there. And so the City of Union City Environmental Division, the code enforcement, because they also handle the environmental stuff, they came out. And as Fairburn Ready Mix was pouring concrete, they were like, where is your concrete washout? Because I had like 6 lots, maybe 5 lots. Yeah, they were all by each other. So they were just washing out concrete onto the other lot. The city came at Union City Code Enforcement, and they basically tried to shut the job down. Fortunately for me, they came towards the end. But unfortunately for Fairburn Ready Mix, although I should have been the one to blame, code enforcement gave them a citation and a fee. And they had to pay it because as a concrete company, they are not supposed to come out there, pour concrete, and then wash it out. They know better. So they know as well. They're going to act like they don't know, but they know. So usually they're supposed to ask you, where's your concrete washout? And in many of the times they get away with it because nobody's enforcing it. But yes, they are enforceable. You are supposed to have a concrete washout. That is an environmental thing you have to do. And if you don't do it, you could get fined. And they did get fined. It happened. They didn't tell me how much, but they refused to come and pour concrete for me when it was time to do my final driveway. You know, so I had to go with somebody else.
Thank you. Got one more question.
Go ahead.
Hey, Al, is there a difference between in the concrete between the slab and the wall, or is it the same type of mixture?
All right. So good question. In this case, it's the same kind of mixture. When you call the concrete company, they're going to ask you that. They're going to ask you a few things. One, they want to know, is it residential or commercial? So if it's residential, then it's going to be 3,000 PSI. They're going to also ask you, you know, are you pouring a smooth slab or are you pouring, let's say, a driveway, something exterior? They need to know so they can get you the proper mix. And then they're going to ask you how many yards you need, which that's what I'm saving for the end. We're going to calculate that. So everybody's going to break out your pencils. And then they're going to ask you if you want fiber. So sometimes, depending on the weather situation, you want fiber to harden up the concrete a lot quicker. You know, so sometimes your concrete guys will ask you that. They'll be like, hey, you know, I need fiber or the fiber. Another thing they'll ask you, which is in the video, is, let me bring out the site plan so we can make sense to everybody. They're going to ask you, is there going to be a pump truck, or is there not going to be a pump truck? So the reason being, y'all see the site plan right here? Y'all see where this house is? Y'all see the distance from the house to the street, right? When the concrete truck comes out, they can't reach all the way out here to pour in all the footings and pour in all the slab. They can't do that. So normally we have to put a pump truck on this side right here, okay? And this pump truck is gonna take the concrete truck when it comes out. When the concrete truck pours this concrete into its chute, the pump truck then shoots it out. And then lets it, it fills out the footings and it fills out the slabs. Now, there are two pump trucks, and there's only one that the concrete company cares about. There's a line pump. So when the company's asking you, do you have a pump truck out there? They need to know, is it a line pump? The line pump is going to be, it's like a small camper almost. It's like a small little unit on wheels, right? And it has a hopper that they're going to pour concrete in. And then that pump truck, that line pump is going to shoot the concrete out to out here. Now that line usually is like 2 inches or 2.5 inches thick. So they're going to ask you, is it a pump truck, meaning a line pump, and how many inches is it? So you tell them it's a 2-inch line pump or a 2.5 inch or 3 inch or whatever it is. And they will create the mixture for you so that it won't be as thick. Because obviously you can't stick it in, you can't make a thick mixture and put it in a small line pump. There's gravel in it and everything. So they give you a different mixture that allows the line pump to pump it out. We've had situations where trucks were ordered, and immediately when they reached out there, they saw that it was a line pump. They had to leave, head back out, and then get the right mixture and come back. So you want to avoid all that. You want to avoid all that and let them know, this is what I need. This is the line pump we're using. In our case, when you see the video, we had a pump truck. So that's the difference. The pump truck, it's a boom truck. It's what we had. So when you look at the video, you got to look at it. You're going to see a big boom. It's going to be pretty huge. I might be able to pull one of it up and see. It's going to be a pretty big boom. It's going to extend all the way out. And then that one takes regular concrete mixture. So the concrete goes in, and then that mixture comes out, and then the boom truck brings it all the way out here. It looks like a little 4-inch pump, and then it shoot, and then it all comes out. And you'll see in the video, you'll see the guy standing there, and then directing the chute is a guy with a remote control, like a little joystick. I mean, he having fun. And then he just directing the joystick. He's just directing the boom, moving it where it needs to go. And then the workers are holding it and just directing it right into the, the footends and the slab area, and then they're pouring. And then the work goes on. So all that's in your video. You're going to see all that. Any questions? All right. So, okay. So you're gonna see all that. And look, feel free, like I said, when we do our Q&As, we can go back to the beginning. It don't matter. If you have questions from the beginning, bring it up and we'll talk about it. Main thing I ask is look at the videos, put down your questions, and then you bring it up and we're going to discuss it, But in the sake of keeping things moving, we'll discuss the topic at hand, but we'll tackle any topic that we've touched. Because now we're preparing to get into the framing phase. Since the slab is poured, we're about to start preparing for the framing, which means we're going to discuss this part. We're going to discuss this part, the floor system. We're going to discuss the wall system, the 9-foot wall, and then the 8-foot wall for the second floor. 9 foot for the first floor, 8 foot for the second floor. We're going to discuss the windows. We're going to discuss how the framing will be, how the wall is going to look like. It's going to look just like this. You're going to see the guys frame it out, then they're going to raise it up, and then you'll see the walls coming up. You're going to see the headers. You're gonna see the headers. And there's so many things that goes into these, you know, depending what county you're in. You know, like how many nails got to go in here, how many, that'll be on the next topic. But for now, we're also going to discuss how we break down how much materials we need. So it's going to get more intense as we talk about our material list, because, you know, we will send plans off to get a package material list from the vendor that we're going to buy from. But it's also good for you to know what it is you're getting. Right. So when the vendor gives you a list and say you need this much 2x4s, or this much 2x6s, or this much 2x10s for your header, you know, it's like, how are they coming up with that? So we're going to go over all of that, you know, in the next phases. But back to this particular program, what I
I
mentioned
got
was,
I got
go
one
ahead.
question.
Now go ahead.
For the property with the retaining wall,
Yes.
since we have to make so many changes because of the retaining wall, um, due to the property, as in changing windows and changing doors and stuff like that. When they come out and inspect, do we need to come up with another plan so they can see those changes?
All right. Good question. Good question. So let me tell y'all what he's talking about. If you didn't see the rest of the video, in the video, I discussed how the second house that we're building, next to the one that we just poured the slab, okay, we poured footings for that one already. And I actually show it in the video when we poured the footing. So when you go through the video, you'll notice that there's that first house that was done, and then I have the second video which shows you the house where we had to make changes. Okay, I want you to definitely look at that, because it's the same house we're building, it's just flipped. We've just flipped the house. So one house is all good, there's plenty of space, right? There's plenty of space on the house, there's plenty of space in the backyard, we have a patio back here, everything. The second house, however, because of the elevation, as I was sharing with you, you almost got 800. Your elevation right here, you got 799. It goes to 800 right here. You see that? So from 800 to where we're settled down here, about 795, which is about what's going on here, that we cut all this down to, right? We discussed how the elevation works. We went through that the last few sessions. So you can see that from the front, you at 790. At the back, you at 800. That's 10 feet. From 790 to 800, that's a 10-foot elevation from here, increasingly going up. All right. So back here, we built this up some, and then we cut the rest of this out. So we made all of this pretty much leveled at around 795. So roughly there's a 5-foot drop. But back here, we couldn't clear this out, because in the site plan, it shows that there's an easement back here. Okay, but there's also underground fiber optic line. Y'all see that? It's on the site plan. So this is something that we see. So as a result, we really can't come out here and dig all this out, because the simple answer would be, well, look, we got all this yard space. Why don't we just cut all this out, just dig it all out, put a wall back here, a retaining wall, and then we got all this backyard. We can't cut this out. We can only go but so far. So as a result, all back here is roughly at the same elevation, the 797 to 800. So it's high. And then you step down about 5 feet and you have all of this. So what we did is we had to put this back here is no longer going to be framed. Back here is going to end up being a wall. Okay, let me see if I can pull it up for you. So this is the front. We got the left side, we got the right side, we got the rear. This is what we're talking about. This is what Eric was talking about. So when you look at this, y'all see this, right? This is the back of your house. On the first house, when you open this back door, you're going to have a patio here. And that's all good. On the second house, you're not going to have a patio because back here, you have a wall roughly. Hey, let me see if I can pull it up here. See if we can do that here. Because this is what I use to actually show the changes. But roughly, you have a wall. So I can get to the. All right. This is what I used in the video. So I came here and y'all can see it, right?
Yeah.
I'm gonna blow it up a little bit. So what I did in the video, I was showing you that when you come to the back of the house, you have a wall back here, roughly a 5-foot wall going all the way across here. Okay. So what that means is for the whole back side of your house, you don't have the ability to have these kind of big windows, this back door, this window by the kitchen. You don't have that. You lose that ability. Okay. And so what you're going to end up having is, this is your drawing. So back here, this is your kitchen. This is your door. Y'all see that? This is your back door. That's here. This is your back door. So from here, you have 3 windows. 1, 2, 3. That's your 3 windows. 1, 2, 3. Okay. And then besides your window, you have on the other side, you have your sink. You have your sink. So your sink has a window above it. That's this. This is your sink with the window above it. Okay. So here, this is your office, right? This is your office right here. This is your office. So you can see this office is not the same level. It's not on the same level as your back is. Your back goes in, then it's indented about 10 feet right here. You come at about 10 feet, and then your office line goes out. What we did is we came in here and we built a wall that's going to come all the way here. That's the back of your house now. But we extended that wall out to hold back all of this dirt that's back here. That way we can have a small little area right here for a patio area. So when you come out, so what I ended up doing is I said, okay, we have to make some changes. So what Erica's talking about is, since there's a wall here, and since we now have to make some changes, as in right here, we have the left side, right? We have, this is the back of our house. This is the office. So when we come from the back of our house, the wall extends out all the way out here. And then we're going to put some steps that go up, and then back here is the whole backyard. So since we have these changes, we no longer are adhering to these plans, because with this wall, which is going to be part of our house, okay, so this side will not be framing. This will be concrete, and then we're going to backfill it. So when you're standing at the back of the house and you look at the house, all you're going to see is dirt and concrete that's covering this side. And then your framing will actually start on top of that wall and go up, almost like how a basement is. So we're going to change these windows and make them smaller windows, okay, to give us some windows here. This door has to go because there's a wall here. This window also has to be changed and made smaller. In doing so, we have to now have we have to change some things around. Okay. And those changes that we decided we're gonna make are moving. We're gonna move we're gonna move some plans around. Okay. So what I had in the video is I said, okay, we don't have this door, but we need a door. We got to have a way to get out of this house. We have to have an egress out of this house. So what I decided to do is that after this pantry, there's a space right here, because remember, I'm bringing this wall all the way out. I'm going to pour concrete here and make this my patio, because I can't get back here for a patio. I'm going to take this door and move it and put it here. So that now when you come through your kitchen, yes, your pantry will be here, but you can walk out your back door into a patio. There'll be a wall here, concrete here. This is your patio area, and there'll be steps that will lead you out so you can access your backyard. But in doing that, I moved this door here, but I'm going to move this stove. But where did I decide to move the stove? I said, well, I'm going to move the stove to here, to where the sink would have been. And then since we have this nice big island here, I'm going to move this sink and dishwasher into my island. Okay, that's what I decided I'm going to do. I'm going to move that into this island. It'll be a good look. And then we can move the stove here. So now you now have a way to exit out of your house. And that is the fix. To answer your question, yes, we should make these changes on the plans and put it out there. However, DeKalb County doesn't really care. When it comes to DeKalb County, all they care about is your site plan. They want to make sure that your site is right, your house is situated right, and that you're building within your confines and adhering by the rules. They could care less if I twist this kitchen this way, that way, move the living room here. They don't care. Now, City of Atlanta will care. City of East Point will care. Practically any other city will care. So the best thing to do, if you're making changes, is to get the plans redrawn to fit your changes so you can have that plan on site. Some cities become very petty and say they want you to pass it through the permit process to get an amendment on your building plans. So that does happen. They're going to say, okay, take this in, resubmit it, and get an amendment. So while you're working on your house, you can take it in and get it amended and approved. Then you can bring it back on the site. But in DeKalb County, we're not going to have that issue. So, but in best practice, yes, you do want to change that. So it is this one that I said we poured the footings already for the wall. We passed the inspection for the footings. We poured the footings. That's in the video. So this is one case where we poured the footing ahead of time, because in order to pour a wall, and this is some information for you, when you're going to pour a wall, you need to pour the footings first. Okay, I had one contractor that said they wanted to bid on the project, and they were like, yeah, I'm going to do the wall. And I was like, okay, I'm like, how you going to do the wall? You know, I just want to know. I'm just going to play it dumb. He was like, oh, I'm just going to get some wood and frame it, and we're just going to dig everything out and dig the footings. We're going to pour everything one time. No, we don't do a monolithic pour for a wall. We get the inspection passed, and then once we pass inspection, we pour the footings. When we pour the footings, we're going to stick in some rebar, some high rebar. You'll see it in the video. You'll see some tall rebar. And then when that footing dries with the rebar sticking up, we're going to come back with the forms. Okay. I don't recommend wood forms. People do it. It's not going to be straight. It'll be crooked. It bends, it bows. You get these forms, you'll see it. I was even tapping on it. You can feel the metallic forms. They'll form the forms, and then you'll pour. And I'll share a video with you after the lesson is done tonight that I took on site. And then you'll see how the form looks. Tomorrow, 10 o'clock, if anybody wants to come on the site, we will be there pouring the concrete for the forms. It's just going to be just one truck. All right. So yes, that's what's happening there. Eric, normally the best thing to do is to revise the plan and put it on site. Some counties will make you do an amendment. Okay, DeKalb County, they don't care. Not to say you don't want to do it, but for best practices, you want to do it. So that's a good question. Anybody else?
All right.
Y'all ready to do some math?
Yep.
You said no?
Yeah.
All right. So we're just gonna take basic. We're not gonna get too deep into it. You know what I'm saying? We're just gonna calculate it out and see how good we get. So everybody, let's get ready. Let's get ready. Let me see right here, man. If I can get this. I want to get to Google. How to calculate volume. So everybody could do this, you see. So I just went to our good old friend Google. This looks like our footing, don't it? Y'all see that?
Yeah.
So to calculate volume, it's gonna be your length times your width times your height. And y'all thought y'all never gonna need math again. Here you go. So you got your length, your width. It seems pretty simple. And your height. But to make it very simple, I'm just going to give you what it is. Okay. So when we calculate volume of a cube, even when we do concrete. So what we'll do, we're going to take all of that. I'm not going to get it too complicated for you, believe me. It'll be simpler than it looks. You're going to take your length times your width times your height. Okay. And then you're going to divide it, all of it. When you get that measurement, you're going to divide it by 27. And then that basically becomes your cubic yards. So you could look at how to calculate a cubic yard. Oh, they cheating. They just give it to you. No, we don't want that. So they're asking the question, why do you divide by 27? We're not going to get into all that. But just know that's the formula, okay? So when we look at our footings, we know that based on our detail, when we get to the detail page, y'all ready? I need everybody to be ready for this.
Yeah.
All right, when we get to our detail page, what do we have? We have our 1 foot by 8 inches, right?
Yeah.
All right. So let's just take that. We have 2 feet. We're going to do everything by feet. So I'm going to take, and you can do it several ways. You can turn it into inches and then convert it. But let's keep it simple. So we're going to say 8 inches when we take our 1 foot. Our 1 foot is 12 inches. We know that. So that's 12 inches by 12 inches. That's fine. Our 8 inches plus our 1 inch puts us at 20 inches. Y'all good with that, right? Y'all know how I got to 20 inches? Okay. 1 foot.
Yeah, 8 plus 12, right?
What's that?
8 plus 12, right?
Nah. So we got our thing right here says 1 foot, 8 inches, right? See that?
Yeah.
Okay. We're 1 foot 8 inches. So all I'm doing is I'm taking my 1 foot and I'm converting it into inches. And we know 12 inches is 1 foot. So this 1 foot is 12 inches. And then we have 8 inches. So we're gonna add, so I took my 1 foot and I turned it into inches. All right. And then this 8 inches, I'm gonna convert it. I'm gonna add it to the 12 inches. So,
Yeah, I said 8 plus 12.
oh, did
Yeah,
you say
that's
8
what
plus
he
12?
said.
Yeah.
Oh, my bad,
That's what he
Josh.
said.
You was right. I know you the mathematical genius. My bad. He said, I
No, I'm just
wasn't
making
just
sure I'm on the
sportsman.
same page.
We're saying the same thing. So
Okay.
Josh is absolutely right. I'm actually going to turn this over to him. Let's go. Now, okay. So yeah, you're right, Josh. It's 8 inches plus 12 inches, which gives us 20 inches. Okay. Now, if you want to convert that to feet, you would just take this 20 inches and divide it by 12 inches. And that gives you 1.666. It's infinite. So basically, we'll say for our width, we have 1.66 inches. I'll stop it at 2 decimals. Okay? Not inches, feet rather. So what you have here, 1 foot 8 inches, is equivalent to 20 inches, which is equivalent to 1.66 feet. Everybody got that? You're gonna need to know this. All right.
All right.
Ask the question if you got it. If not, we could keep moving. We're good? We got that part?
Good. Yep.
All right, cool. All right, so we got that. So we got 1.66 inches. It's right here. Now, we know that our depth is 2 feet. Okay? So call that our height. This is our height. Based on the formula, length times width times height. This will be our height, 2 feet. So since we're using feet, we're going to keep that there. So we got 1.66 times 2 feet. So we got the width, we got the height. Okay? Times, so I'm going to multiply that by 2, times 2. Okay? We got 3.33. Well, that 3.33 has to be multiplied by our length. So what is our length? Well, let's look at this. Our length is all of our footings perimeter. Okay? All of this. So y'all got to work with me on this, man. Let me see if we can make it as easy as possible. So let's break out our phones. So I got my phone right here. So let's start. Break out my calculator. So we'll round some numbers off, you know. So let's say from here to here, y'all see this?
Yep.
From here to here, it's showing about 19 feet, 4.5 inches. I'm gonna just go ahead and calculate it off as 20 feet, okay? So we're gonna say this, we're gonna round this off to 20 feet because it doesn't hurt to be a little bit over. We'd rather be over than under. So let's call this 20 feet. Now, from here all the way to here, meaning from here to here, we have 19 feet, 11.5 inches. Might as well call that 20, right? I'm going to add 20 feet. So we got 20 feet plus 20 feet. And then we got this part right here. Y'all see that? 5 feet, 5.5 inches. I'm going to call that 5.5 feet. Okay. But like I said, I don't mind going over a little bit. So we're just going to go to the next whole number. So we're going to say this is 6 feet. We're going to call that 6 feet. Then we're going to go here. From here to here, we got 4 feet, 7.5 inches. I'm going to call it 5. Then we got 9 feet, 9.5 inches. I'm going to call it 10. So I got about 61 feet so far. From here, through here, I got about 61 feet. All right. And then we're going to go up. So from here to here, about 3 feet 10. I'm going to call it 4 feet. From here to here, we got about 14, 1.5. I'm going to just call it 15 feet right here. Then we're going to turn. Now, what we have here, we're going to take it from here all the way to here. We got 10 feet. Yeah, that's basically 10 feet. We're going to do 10 feet. 5.5 plus 4.5. I'm going to say 5 plus 4 is 9. 4 and 4, we'll call it 10 feet, right? These right here, we're going to call it 10 feet. Over here, we got 15 feet, 11 3/4, so we're going to call it 16 feet. Okay. And then down here, we got 10 feet, 1 1/4. I'm going to call it 10 feet. Here. So we got our 10 feet here. Now we got to go here. All right. We came down 10 feet. Now we're here. This is 12 feet. You see from here? 12 feet, 4.5 inches. I'm going to go on and call it 13 feet. I'm rounding it up. And then we come here. We got about 14 feet, 11 1/4 right here. I'm going to call it 15 feet. And then we come back across again. We're looking at the same 12.5 feet, 12 feet, 4.5 inches. I'm going to call that 13 feet again. And then right here, we got about 4 feet, 3.5. I'm going to call it 5 feet. And then right here, we got this little shot. 6 feet, right here. We're going to come across here about 6 feet. I'm going to call it 6 feet. And then right here, see, we got about 5 feet. Now, y'all remember the other classes I told y'all, if y'all printed this out and y'all didn't have all the measurements, y'all can take that ruler and measure, and it will give you that scale. Okay, so we're here, 5 feet here, then we turn this way, another 10 feet, 4.5 inches. I'm going to call it 11. And then from here, all the way down to here, we got 23 feet, 5.5 inches. I'm going to go in and call it 24 feet. So based on this, what we just did, I came up with 218 feet. So our calculation that we have, which is 3.33, which was the 1.66, which is the right here, 1 foot 8 inches, times the 2 feet, right, which is right here, the 2 feet, times the length of everything of our perimeter. Okay, that gave us 218. So I'm going to multiply that by 218. What does that give us? 726.666. We're just going to say 726.66. Now, what do we do after we get that number? That's our volume. Now we're going to go for cubic yards of concrete, so we know how much concrete we need. And that's just for the footing. We're going to divide that by what? I think I told you the formula is 27, right? So when you divide that by 27, that gives you 26.9 yards. Call it 27 yards. Okay? That gives you 27 yards. Now, quite amazing, isn't it? I say that because for those that were there, for Fode and Eric, y'all were there.
Yeah.
Y'all recall it took exactly that, didn't it, to do the footings?
Yep.
It took
Yeah,
3
it was,
trucks.
yeah, because it was
Remember?
what, it was 9 yards per truck.
Okay, so all of
Right.
y'all understand this. A truck, a concrete truck carries a maximum of 9 yards, your typical concrete trucks. So when they send out 1 truckload, that means you're going to pour about 9 yards. So our first 3 trucks was, so if you take 27 yards, which is what we see for the footings, and you multiply that, or rather divide that, sorry, by 9, because each truck is going to carry 9 yards. That tells you how many truckloads you're going to need. So for the footings, we have calculated 3 trucks at 9 yards each. For us who are on site, we're working this backwards, but it makes perfect sense. It's exactly on point. So that means that our footing was dug damn near perfectly because it meets exactly the criteria that we're given, which will calculate how much concrete we need. So before they went out to order the concrete, we could have easily said, I need 3 trucks. So when you call the company, they'll ask you, how many trucks do you need or how many yards? So we can say we need 3 trucks for our footings. How? We calculated it. We added them for a little bit extra maybe, but we're calculating that 3 trucks is going to take care of our footings. So if you get somebody coming out to the site and digging your footing too big, maybe they dug it 2 feet instead of 20 inches. By the time you reach all of this perimeter, you would have poured a whole lot more concrete than you needed to. And by the way, it happens. Some people over dig their footings and then you end up spending more. So in this case, we got 27 yards for the footings. Well, what about our slab? Because remember, if we were pouring this separately, after we passed the footing inspection, we would have to order the concrete to pour. And then we would have only ordered 27 yards of concrete based on our formula of the height, the width, and the length, divided by 27. So now, how do we do the same thing for the slab? Because now we passed everything. Now it's time to do the slab. Well, we're back to the drawing board again. How do we do it? We're going to make this one easier because I'm not about to sit here and calculate all this stuff. But what we're going to do is we're going to take basically the square root, the square feet rather, not square root. We're going to take the square feet that we have here, okay? Because that's all we'll be doing. I'll be calculating length times width, length times width, length times width, adding it all up. Well, that's been done for us already because our site plan basically shows us what our slab is going to look like, right? Shows us right here. So what I have to do is go to the building plan and look for my house and garage and porch. Y'all follow me? On the building plan, these measurements are out here for you. So my house and garage coverage, which is basically your site plan. Let me take that back. Not so much your building plan, but your site plan. Your site plan shows your foundation structure. And that's what we're about to calculate the slab for. So I will cheat. I'm not going to do all this crazy mathematics. I'm going to go ahead and say, okay, my house and my garage is 2,018 square feet. I have a covered porch area, which is basically, let me see it. I have a covered porch area. That's the rear. Which is right here. We got a covered porch area right here. All right. So that one is on your site plan. And then it's also in your building plan. So go to your building plan. So you have a covered porch area, which is right here. Okay. So it gives you the covered porch area, 32 square feet. So we're going to add that as well. So we got 2,018 square feet. We got 32 square feet for the covered porch. We're not doing the driveway, but we definitely have this area and that area. Remember, I told y'all that I added a 10-foot by 8-foot patio in the back of the house. So let's put that in there. That'll be another 80 square feet. So let's look at this slab because this is important. So we're going to add all these numbers up. Okay, the house and garage, the cover porch, and the patio. Let me bring out my calculator. So when you go to calculate your slab, that's what you're going to do. So you're going to, so you got 2,018 square feet plus 32 square feet. Oops. Let me do that. Got 2,018 square feet plus 32 square feet plus 80 square feet for the patio in the back. Okay. So altogether, I got 2,130 square feet. All right. Then we go back to our plan right here. And we're gonna go to our foundation plan. And remember, what did this tell us? This told us what? We got 4 inches of slab, right? Y'all see that?
Yeah.
We got 4 inches of slab. So what that means is we have to convert that slab 4 inches into feet. So we're gonna say 4 inches, and we're gonna divide it by 12 inches because 12 inches is 1 foot. And it's gonna convert the 4 inches into feet for us, which 4 inches in feet is 0.33 feet. Okay. So remember, it's length times width, or, you know, your full length, your width, your depth, or your height, right? So our length and width gave us our square feet. Our height is 4 inches. That gave us 0.33. So we're going to multiply the height, 0.33, times our length and width square feet, which we have, which we said is 2,130. So that gives us 710, right? The total number is 710. That's our volume. Well, what do we do after we have that? We divide it by 27. And that gives us our yards. Okay? That gives us, in this case, we have 26 yards. So you would say that your slab is 26 yards, or we'll round it up to, let's say, 27 yards. So roughly, we're gonna say, well, we're pouring three trucks of the footings and 3 trucks of the slab. In our case, we actually poured roughly, we poured about 7 trucks altogether. So we have an extra yard. We have an extra truck of concrete. We had 3, and then we poured 3 more, and then we ordered 2 more trucks, which poured, let me see, I even have the paperwork here. You know something, Eric? It was very interesting because after you left, we had ordered a couple of trucks, and I thought we counted the trucks. We were actually counting wrong. Fode, you remember that?
Yeah.
Yeah, we were actually counting. We thought that we had more trucks than we thought we had less trucks. We thought that came out further. So no, I take it back. I take it back. We actually ended up pouring with 7 trucks because the 5th truck that left, I thought was the 6th truck. The rest of y'all may not know that we were counting the trucks as they were coming, but we miscounted one because on the 5th truck, I called to order 2 more trucks, and I thought the 5th truck was actually the 6th truck. But when I called them, they were like, nah, that's actually truck number 5. It's leaving. The 2 trucks you ordered more is coming in. So actually, this works out exactly as it should be because we ordered 7 trucks. 6 trucks, meaning 27 yards for the footings, and another 3 trucks, so call it another 27 yards, for the slab. And then the last truck, the 7th truck, we used that to pour the footing on the next lot. So this house took roughly 27, 54, right? It took about 54 yards. So that's the mathematics of it. That's the calculation. And that's
Is it
what
always like that, or is that just a coincidence? Like, is it always the slabs equal to the
not at all.
exterior? Okay.
Yeah, it's not always that way because you don't always have to have a 20-inch and a 20-inch width slab and a 24-inch deep slab either. Sometimes sometimes they're like 18 inches. You know, sometimes it's 18 inches by 18 inches. The smallest I've seen is 12 inches wide and 12 inches deep. We've actually passed some inspections like that. It's all based on what the plans call for because the engineer is the one that has to back it up. So in this case, it works out pretty close because the width of the house. So imagine this, Josh, if we had like a smaller house, you know what I'm saying?
I got you.
Yeah. So the width is still, you know, but so it's not, it doesn't always correlate to answer your question. It depends on the dimensions. And also, if somebody was doing 4-inch slab or 8-inch slab, or in some cases, we have to raise the slab because maybe the foundation where it is, we need it to be a little bit thicker. So we probably end up putting on like a 6-inch slab or 8-inch slab on one side. All that will be a factor, you know. So whereas we have 4-inch slab here, there's some areas that were a little thicker than 4 inches if you look at it. And then you have the patio area, which is small. That's a 4-inch slab, definitely. It doesn't get any bigger than this, you know, but it doesn't have the gravel and stuff underneath it either. You know, so that's basically how we calculate that. So it's your length times your width times your height, all of it, you divide it by 27, and that gives you your volume of your yards. Now that's for your concrete because you're doing volume. Later on, when we calculate yards for, let's say, our carpet, is going to be different. It'll be a different calculation. Okay, so there'll be some formulas that you'll get used to, but for the most part, this gets you through your footing, your rebar, your gravel, your plastic, your plumbing that goes before that, you know, and then everything that's poured, and then your concrete that you're gonna order. And like I said, it's very important because somebody will come and quote you 80 yards and you won't know the difference. They might pour just 54, but they'll come look at it and tell you, oh, you need 60 something, 70 something yards. And how would you know? You know, unless you sit down and break it down, that you can challenge them. Yeah, you can count the trucks, but what does that mean? Even me being out there with Fode and, you know, and Eric, after Eric was leaving, I believe we were counting, we kind of miscounted one truck. I had to actually talk to the concrete company for them to verify what the trust word that they sent me. So this is very critical to know. All right. So nobody could cheat you on that. And that's where we are right now. And actually, the next day they came and took all the forms off of it. Let me talk about something that came up on site that Eric had brought up before there when we were talking. The question was, who is responsible for framing this perimeter of this house? Whose job is it? Eric and Fode, y'all can't answer this. Anybody got a question? Got a shot? Who's responsible for framing this whole perimeter where we're gonna pour this concrete? Does anybody know?
Is it the concrete guys?
There you go. It is the concrete company. The guys doing the concrete specialists are the ones to do it. Okay, because y'all remember in the beginning when we talked about the survey company coming out, putting the stakes out so we can stake the corners of the houses. And I told y'all you gotta use the survey companies. That's what you want to do. Okay. You want to use those survey companies. They're going to come out. They're going to put the stakes out. They're going to locate the corners. And based on the corners that they locate, they put little 5 feet offsets on these. And so that way, when you remove the corner and you grade and clear it out, you can use these offsets to locate the corner of your house. So the concrete guys, they know this, or at least they should know it. Don't always believe them. They'll come out. So you want to use the professionals. They'll come out, they'll stake it out, and they'll do the forms. They should use laser. You should see them with their laser out there, shooting the grade, shooting the forms, make sure everything is level, okay, and have a proper grade to it. And then they will use that to form all of this, because it is based on this, as I share in the video, that the plumbers can go now and figure out where everything goes. That's how they know where their kitchen is. That's how they know where their bathroom is, because they got to go by this frame. All right. One more thing before we kind of wrap this up or get further questions. I had a guy with me today at Home Depot, somebody I've known for a long time. And he was expressing his frustration to me that they got messed up on a couple of houses they were building. So they went out. They decided they're gonna frame out the house themselves with whoever they had, whatever handyman they had, I guess. He knows what to do. They framed out the house, blah, 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 did all that. He's talking about they got the house framed up. And then the city, I forgot which city they're building in, because I think I told you on one of the courses that some of the cities, they do come out to inspect the as-built, meaning they want to know that your house is situated on the site plan as is indicated when you turn it in for your permit. So they want to make sure that you got that 22.5 or setback. You got this 20.1. You got this 26.8, 30.4. They want to know that. So they ask for an as-built survey. So after this is done, after we pour the slab, they'll require us to get a survey. And the survey company has to come out and basically confirm that we did this. Well, they went out there and they staked the house out however they felt like. And he was like, they got hit with that as-built survey situation. Well, when they got there, he said the house was crooked. It wasn't facing the way it was. It was turned. It was out of line. They're in trouble now. The job is stopped. And I was like, you should know this by now. You know, you've been doing this for a minute. So don't get it twisted, man. People do this. So it's up to you now, because now you have the information. It's your job to be on top of it. It's your job to be on top of it. Get the survey company, because if they mess up, guess what? You can sue them. They have insurance for this. You can sue them and make them fix, they'll fix whatever. So when they come out and do their job, you can rest assured you should be good, because you did it by the professionals. Okay. Yeah, I think that's another thing I wanted to share. So any other questions? Because I'm gonna let y'all calculate the next concrete that we do. We got several houses to build. Y'all gonna give me the calculations on that. Are there any questions on this before we move on to wrap it up and then get ready for next week's information? We're good? All right.
Yes.
All right,
All
cool. So
good.
look, review the videos, y'all. Review the videos, check it out. Let me stop this little recording here.